Homework 4.1, Video 6, Transformations of Graphs. This and the next video will be associated with homework questions 8 through 11. In this video, we're going to develop some rules for how putting extra numbers in a function, add or subtract at the end, add or subtract in the exponent, or sticking a negative in front or sticking a negative on the exponent. We're going to see how those actions alter the graph of the function without it. And I could just tell you, but this is a good Desmos moment. So I'm about to sit down in front of my laptop and I will be going back and forth between the board and Desmos as we discover the effects of these extra values or negatives inside of a function. Let's disconnect from the computer, I'll leave it in the tripod. Okay, so let's talk about what we're going to do. So I've got a table set up here, and in the left column, we're going to talk about the graph of an exponential function with an extra value added or subtracted somewhere, or an extra negative inserted in the function. And on the right column, we're going to categorize the change it has on the graph of the function without that number. So as we discover them, we'll write the results in red. So let's start with the first one that says f of x equals b to the x power plus c. Now, for this particular example, I've already got an exponential function set up in Desmos. The one I have set up in particular is f of x equals 2 to the x power, the one that we've been using. And it's that graph in red, and if you notice, I've got a couple points already labeled on it. The y-intercept and what I casually call the base point, because the y-coordinate is the base of the function. But I've also got another graph set up that's going to be in green, so there it is. And that graph has a plus c on the end of it. And I've got a slider set up so I can change the value of the c. Right now it's set at 0, so this says 2 to the x plus 0, which is just 2 to the x, which is why the green graph that's about to move along with the red graph are currently sitting in the same place. But I'm going to grab this slider and I'm going to slide it to the right. And what that's going to do is it's going to put a positive number here. What do you think is going to happen to the green graph? I'll give you a hint. It's going to move in a certain direction. But if I add a number to the end, which direction do you think it's going to move? I'll give you a hint. Think about what adding a number to the end does to the original y values. For example, these two y values are currently 1 and 2. But if I add more to that, what's going to happen to them? The y values would get higher, which means the point should get higher, which means the graph should go up. So I'm going to slide the slider to the right, and there goes the graph. I have it moving its asymptote also. And if you notice, I'm keeping track of those original 2 points. So for example, right now, I've got the slider set at 3 right here. And so it's thinking that the green graph is 2 to the x power plus 3. And if you'll notice, the original y-intercept, which is right here, moved up 3. And the original point at 1 comma 2, stop that. Come on. The original point at 1 comma 2 moved up 3 to 1 comma 5. So all the points moved up 3 because of the plus 3 at the end, as did the asymptote, which is now at y equals 3. Y equals 3, and not at y equals 0. So I think we can say confidently that the effect of adding a number at the end to a graph changes this graph by moving up c. Now we are assuming that the c is a positive number, so I should stipulate here that c is greater than 0. And the only reason I'm saying that is because this looks like we're adding a number and I want it to actually represent adding a number. If it were negative, then it would be subtracting a number. So we'll assume that the c is actually a positive number, so that plus c actually is positive and minus c is negative. Speaking of minus c, if we add a number to the end, it moves the graph up. So what do you think happens if we subtract? Your instincts would be correct if you're saying it moves it down, but let's just not guess. Let's get some evidence to back it up. So what I'm going to do is I'm going to move this green graph back down. to where it originally was. Oops. I don't want that to be negative. I actually want this to say minus c. I'm going to make one more change here. Trust me. Okay, so now I'm going to take this slider and move it to the right. Hold on. Okay. Don't need that. Okay, so now I'm going to take this slider. Where's the arrow? There it is right there. And I'm going to move it to the right, which is going to make the c a bigger value. So I'll be subtracting a larger number. Now the suspicion is that everything's going to move down, and you would be correct. So let's put it right there. So right now it's thinking the c is 3, so this says 2 to the x power minus 3. And if you notice, the y-intercept, which was originally at 0, 1, did move down 3. And the point, the base point at 1, 2, where are you? There you are. Come on, a little bit more, a little bit more. There it is. The base point at 1, 2 did move down 3 spaces to 1, negative 1. So your instincts would be correct if you said that subtracting a number from the end changes the graph by moving down c. All right, so adding a number at the end moves the graph up, subtracting moves it down. But what about adding or subtracting a number directly to the x? That one may not seem intuitive, but let's figure it out. Okay, so let me restore this back to center. So put the slider back down to 0. Okay, now I need to change this graph, this function. I need to go up in the exponent and put a plus. I need to go up in the exponent and put a plus. Okay, you cannot defeat me. Let me put that x in parentheses, and then inside the parentheses put a plus c. I'm going to make it look exactly the way I want. Let's get rid of this. There. Ha, you cannot defeat me. All right, I also need to change this because we're adding and not subtracting. Okay, so there's the original. There's a plus number up in the exponent. Right now it's plus 0. I'm going to slide the slider to the right so that this becomes a larger number that we're adding. Which way do you think the graph will move? I'll give you a hint. It won't move up or down because we already know when it will do that. So it's going to move left or right. Which way do you think the graph will move if I take this slider and slide it to the right to make this number get larger and larger? Your instincts might say it's going to move to the right. What is going on here? That should not be... Oh, sorry, hold on. I don't know what's going on. It's giving the illusion of moving up because I forgot to change the asymptote so it doesn't move, because it's not going to move up or down. It's going to move left or right. But which way will it move? It may not look like it, but it's moving to the left. It looks like it's stretching upwards, and in a weird sense it is. But if we add a number to the x, the graph slides to the right. And let's see, how can I keep that? Okay, I know why it's doing that. I should have set this up a little bit better before. Give me 1 second. I'm going to change the way the points are set there. So we need to put the point negative c, comma, g of negative c. Is that what I need to put? Sorry, I'm thinking out loud here. I think that's what I need. Let me see. Yes, okay. All right, so now that I know what I'm doing, give me 1 second here. Now that I know what I'm doing, sorry, I thought it would be easy to just change it to go left to right like I changed it going from up to down. So again, I hate to reinvent the wheel or invent the wheel on the screen, but I don't want to stop the video because I've gone this far. I'm just making it do what I want to illustrate what's going on here. Okay, let's label that too. Okay, so let me put the slider back at 0 for a second. Sorry, folks. I know that wastes time. Come on. I may need to put the camera down. Okay, so there we go. All right, so Again, don't look at all that down there. So I'm going to slide this slider to the right, which is going to increase the value of C, which is going to add a larger and larger number there, but watch which direction the graph moves. The graph actually moves to the left. You would think it moves up and down. Excuse me, you would think it would move to the right, because you would think adding a number would move it in the positive direction, but it actually moves it in the negative direction. So that's a little bit contrary to what you might think. If you add a number directly to the x, it actually changes the graph by moving left C. And because this video has already taken longer than I wanted it to, I'll just tell you what the other one does, but you could probably figure it out. If adding a number up there moves it to the left, then subtracting a number moves it to the right. So moving to the right, C. So now we've got 4 actions that cause what are called translations. In geometry, a translation is moving a shape without changing its shape. So moving a graph without changing its shape. Plus at the end moves up, minus at the end moves down, plus on the x moves left, but minus on the x moves to the right. The left and the right seem backwards, but they're not. The last two, what happens when you stick a negative on them? Well, we kind of talked about that at the end of the last video, but let's just illustrate it real quick. I'm going to get rid of the slider stuff because I don't need it. So go away, go away. I know you don't know what to do because I took away your slider. I'm sorry. Well, that's okay because I'm going to take away your plus C also. Okay, so really all we want to know is what happens when we put a negative in front and when we put a negative on the x. I bet you know what's going to happen when we put a negative on the front, because it's going to take all the y's and stick negatives on them. So instead of these y's going up, they're all going to go down, and the graph looks like that. So I'm going to do a little action thing here. So sticking a negative in front gives you a reflection across the y-axis. But sticking a negative on the x gives a reflection across the x-axis. So let's just write that down so we can end this video. Putting a negative in front changes the graph by reflecting across the x-axis, and putting a negative on the x changes the graph by reflecting across the y-axis. So these are going to stay on the board for the next video, because in the next video we're actually going to manually sketch some graphs by analyzing how the function has numbers added or subtracted and maybe some negatives, and then performing these moves accordingly and also keeping up with the asymptote and maybe a couple of other points.